Hello, science fans! Dr. Emily Carter here, ready to embark on another fascinating journey into the microscopic world. Today, we're diving into the world of chemistry, the science of substances, and their transformations. We'll be exploring the building blocks of matter and how they interact. And biology, the study of life itself. From the smallest cells to the largest organisms, biology seeks to understand the intricate processes that keep us alive and thriving. To meet a tiny but mighty particle, a fundamental component that plays a surprisingly large role in our health and well-being. Iodide. It's a negatively charged ion formed when iodine gains an electron. You might not think about iodide every day as you go about your daily activities, from brushing your teeth to enjoying a meal. But your body sure does. It's constantly working behind the scenes to utilize iodide for essential functions. Iodide is a special form of the element iodine, a non-metallic element that exists as a solid at room temperature and readily forms colorful compounds, and it's crucial for keeping us healthy. It's an essential nutrient that our bodies cannot produce on their own, so we must obtain it from our diet. Think of it as a secret ingredient, a vital component that often goes unnoticed but is absolutely necessary. Your body needs to work right to maintain the delicate balance of hormones and enzymes that regulate everything from your energy levels to your growth and development. A tiny superhero behind the scenes, quietly ensuring that your body functions optimally. Iodide is a key player in your metabolism, specifically in the production of thyroid hormones, the system that controls how your body uses energy. These hormones regulate your heart rate, body temperature, and even your mood. Without enough iodide, things can go haywire. The thyroid can't produce enough hormones, leading to a range of health problems. We'll explore where iodide comes from, including natural sources like seaweed and seafood, which absorb it from the ocean. How it ends up in your salt through a process called iodization, which adds iodide to table salt to help prevent deficiencies, and why it matters for your health. Ensuring adequate iodide intake is essential for preventing thyroid disorders and supporting overall well-being. From the vast oceans, where iodide is abundant, to the tiny glands in your neck, the thyroid, which relies on iodide to produce its vital hormones, Iodide's story is a scientific adventure, filled with fascinating chemistry and crucial biological implications. So grab your thinking caps. Let's take a closer look at the wonderful world of iodide. We're about to uncover some amazing facts and learn why this tiny particle is so important. Let's get started. The chemical lowdown. Let's dive into the world of chemistry and explore a fascinating element and its ionic form. We're going to unravel the mystery surrounding iodide, but to truly understand it, we need to start with its elemental form, iodine. So, buckle up and get ready for a quick chemistry lesson. To understand iodide, let's start with iodine. Iodine is a non-metallic chemical element that belongs to the halogen group. It's essential for various biological processes, and it plays a crucial role in the production of thyroid hormones. Element symbol 1 on the periodic table. You'll find it nestled among other fascinating elements, each with its unique properties and characteristics. The periodic table is our roadmap to understanding the building blocks of the universe, and iodine is one of those essential blocks. Iodine atoms are neutral, meaning they have an equal number of protons and electrons. This balance gives them a stable electrical charge. But like all atoms, iodine can participate in chemical reactions that alter its charge. But when one gains an extra electron, something interesting happens. This electron transfer is a fundamental process in chemistry, and it's how ions are formed. It becomes a negatively charged iodide ion, symbol Ye. The superscript minus sign indicates that it now has one more electron than protons, giving it a negative charge. This transformation is key to understanding iodide's role in various compounds and biological systems. Iodide ions are too small to see, even with a powerful microscope. They exist at the atomic level, interacting with other ions and molecules in ways that are essential for life. But when they join with other ions, they form salts like potassium iodide. These salts are formed through ionic bonding, where the negatively charged iodide ion is attracted to a positively charged ion such as potassium, a white crystalline solid that looks like table salt. But don't be fooled. While it may resemble table salt, potassium iodide has distinct chemical properties and plays a different role in our bodies. Don't confuse iodide with iodine. They are related, but they are not the same. Pure iodine, I2, is a dark, shiny solid at room temperature. It has a distinct metallic appearance and a characteristic odor. That turns into a purple gas when heated. This vibrant purple vapor is a telltale sign of iodine undergoing a unique phase transition, a process called sublimation. Sublimation is when a solid transitions directly into a gas, skipping the liquid phase altogether. It's a fascinating phenomenon that showcases the unique properties of iodine. Iodide in salt form is stable. This stability is crucial for its use in various applications, including dietary supplements and medications, and dissolves easily in water, making it the form our bodies use. This solubility is essential for iodide to be absorbed and utilized by our thyroid gland, where it plays a vital role in hormone production. So iodine is the element, the fundamental building block. But iodide is the form we absorb and need for our bodies to function correctly. Just one extra electron transforms iodine into iodide, changing its properties completely. This seemingly small change has a significant impact on its chemical behavior and biological function. Science is all about these amazing transformations. It's about understanding how atoms and molecules interact to create the world around us. In summary, iodine is the element, the raw material. Iodide is the ion, the form our bodies can use. And together they play a vital role in our health, particularly in thyroid function and overall metabolism. Next, let's see where we find iodide in nature and how it makes its way into our diet. Ready to follow its journey from the ocean to our bodies? Let's go! Have you ever wondered where we find iodide, this essential trace element? It's a question that takes us on a journey across the globe, from the deepest oceans to the highest mountain peaks. Its main home, the heart of its distribution, is the vast and mysterious ocean. The ocean acts as a massive reservoir, holding a significant amount of the world's iodide. Over millions of years, a fascinating process unfolds. Iodine, originally locked within rocks, is gradually released through erosion. This iodine then washes into the sea, carried by rivers and streams, contributing to the ocean's iodide content. Once in the ocean, marine organisms, particularly algae and seaweed, play a crucial role. They actively absorb iodide from the seawater, incorporating it into their tissues. These marine plants are like tiny sponges, soaking up the iodide that surrounds them. These iodide-rich organisms then become the foundation of the marine food chain. As they are consumed by other sea creatures, the iodide is passed along, moving up the food web. But the story doesn't end there. Some iodide escapes back into the atmosphere from ocean waves through the formation of sea spray and mist. This process helps to redistribute iodide across the planet. This airborne iodide eventually returns to land in rain, enriching the soil and completing a vital part of the cycle. The rain acts as a natural fertilizer, delivering iodide to terrestrial ecosystems. Consequently, coastal soils tend to be particularly rich in iodide thanks to their proximity to the ocean and the constant replenishment from rainfall. As a result, plants and animals living in coastal areas generally have a higher intake of iodide compared to those in inland regions. This abundance supports their biological functions. In contrast, inland and mountainous regions often suffer from iodide-poor soil. This scarcity can lead to deficiencies in the local populations, highlighting the importance of dietary sources of iodide. This natural cycle, with its intricate pathways and varying concentrations, explains why some geographical areas are naturally richer in iodide than others. It's a complex interplay of geological and environmental factors. Beyond the active cycle, iodide is also found locked away in ancient seabeds, preserved over millennia in geological formations. A prime example is the caliche ore found in Chile's Atacama Desert. This arid landscape holds a treasure trove of iodide, making it a major source for meeting the world's demand. In summary, iodide embarks on an incredible journey, traveling from the sea to the sky, back to the soil, and even residing deep underground in geological deposits. It's a continuous cycle of distribution and redistribution. Truly, iodide is a world traveler, constantly circulating and playing a vital role in ecosystems across the globe. Understanding this journey is absolutely key to understanding how iodide ultimately ends up in the food we eat, influencing our health and well-being. Now that we've explored its origins and journey, let's take a closer look at how iodide shows up in our daily lives, often in ways we might not even realize. Are you ready to become an iodide detective and spot this essential element in your surroundings? Let's find out where it's hiding. You probably use iodide every day, especially in the kitchen. The most common source? Iodized salt. Check your salt container. It likely says iodized salt. In the 1920s, adding iodide to salt became a simple solution to prevent deficiency. Iodide is also added to animal feed, so dairy, eggs, and meat can be good sources. Seafood is naturally rich in iodide thanks to the ocean. Beyond food, iodide is in antiseptics like povidone iodine, used to clean cuts. It's also in many multivitamins, check your label. From salt to milk to first aid kits, iodide is a quiet but constant companion. It keeps us healthy inside and out. Next, let's see how your body uses this essential nutrient. How does your body use iodide? It all starts with your thyroid gland, a butterfly-shaped organ in your neck. The thyroid controls your metabolism by making hormones called T4 and T3, which need iodide as a key ingredient. Your thyroid pulls iodide from your blood, converts it back to iodine, and uses it to build these hormones. These hormones travel throughout your body, telling your cells how much energy to use. They're crucial for brain development, heart rate, temperature, digestion, and muscle function. If you don't get enough iodide, your thyroid can swell, goiter, and you may develop hypothyroidism, feeling tired, cold, and sluggish. That's why getting enough iodide is essential for health. It's a tiny nutrient with a massive impact. So, next time you sprinkle salt, remember your thyroid is counting on it. Now let's see how iodide helps beyond our bodies. Ready for some surprising uses? Let's explore. Iodide isn't just for health. It's a star in technology and industry. In old-school photography, silver iodide made film light-sensitive, capturing memories for over a century. Halogen lamps use iodine compounds to make bulbs last longer and shine brighter. Iodide helps create polarizing films for LCD screens and sunglasses, controlling how light passes through. In chemistry labs, iodide solutions are used in titrations to measure other chemicals. Iodide compounds also act as catalysts, speeding up reactions in making plastics and organic chemicals. From photos to lighting to electronics, iodide is everywhere. It's a versatile helper in our modern world. Next, let's talk about safety, because even superheroes need rules. How do we use iodide safely? Let's find out. Safety first. Iodide in food is safe and carefully regulated. Our bodies get rid of any extra. The key is balance enough for health, not too much. Too much iodide, usually from high-dose supplements, can disrupt thyroid function. Always talk to a doctor before taking extra iodide. Some people react to iodine-based contrast dyes in medical scans, so always inform your doctor about allergies. In rare emergencies like nuclear accidents, potassium iodide tablets protect the thyroid from radioactive iodine, but only take them if advised by officials. Used wisely, iodide is safe and essential. Respect the dose and it will keep you healthy. Now let's wrap up with some surprising facts. Did you know iodine was discovered by accident in 1811, when a French chemist saw a violet vapor from seaweed ash? The name iodine comes from the Greek for violet-colored. Iodide is used to test for starch. Drop it on a potato and it turns blue-black. Iodized salt is one of the world's most successful public health measures, preventing goiter and intellectual disabilities worldwide. Organizations like UNICEF and WHO promote salt iodization to improve global health. Scientists are still exploring new uses for iodine and iodide in medicine. From accidental discovery to global impact, Iodide's story is still being written. Science is a journey of discovery. We've traveled from the oceans to your thyroid, discovering how vital iodide is. It's a tiny ion, but it powers your metabolism and keeps you healthy. Iodide's journey explains why adding it to salt changed public health forever. Beyond our bodies, it's helped capture memories, light our rooms, and power our screens. Next time you use salt, remember the science and history behind it. Iodide is a small ion with a massive impact. Understanding it helps us understand ourselves and the world around us. That's the magic of science.